Hello everybody, welcome back to the training of the Modicon M221. In this video we're gonna see how we can communicate the PLC M221 with another device or another PLC using some function blocks to communicate via Modbus Serial between these devices. So let's go to the presentation and see the idea of this test for you to see how it works. So the idea is to have this PLC M172 as a slave in the communication, so we can communicate from the PLC M221 as a master in the communication to read and write information with it, as I show you in this part of the architecture. So you can see here that this is something important in the Modbus communication. We can have only one master, okay, and then we can have several slaves in the communication. Only one master, okay, that in our case is the Modicon M221, and in this case I'm going to use only one slave to communicate. There is some uh, configuration that must be done in both devices in order to communicate, which are the baud rate, the parity, the stop, and the data length, so we can communicate both devices. It's like they talk in the same language, so they can communicate. Otherwise, it's going to be a problem in the communication. So you can see here, I have, or I'm going to have this configuration on the PLC, the M221, and I'm going to have this configuration on the slave. You can see most of them are the same, but on the slave, in order to identify for the master where I need to read information, write information, the slave must have an address. In our case, the slave will have the address 1. Now, what I want to do is to read from this PLC M172 to analog input. And why? Because I have on my demo test only the analog input connected to an NTC proof. And the other thing that I'm going to do is to change the backlight of this display, okay, inside the M172, so we can see how we can write information to it. Now, in order to make this possible, what we need to do is to configure the serial line on the PLC. So far, I'm not going to explain how to configure the M172, okay, because we are going to focus on the M221. Okay, so only focus on the M1 and the M221. So let's continue. So what we need to do is to go to configuration, serial line, and select Modbus. Okay. In this way, we can specify the communication to be serial line as Modbus. This is why it is because we have the possibility to use also serial IO scanner. That's going to be much better, but I'm going to explain that later. So continue with this. This is the thing that we need to match in those devices in order to communicate. Once we have configured as a Modbus serial line, we need to configure this because I have already predefined because I want it. Okay, and this is the configuration on the other side just to show you. Okay, so if I open the other software, which is the EcoStruxure Machine Expert HVAC, I'm connected with the PLC, and you can see over here, if I select all this and read this from the device which I connected, you can see that the values are correct, and if this is correct, we shouldn't have any problem on the same language that they talk. Okay, so that is to guarantee that we are going to communicate with the device. So I'm going to hide this part, disconnect. This part is okay. Now, once we have already configured that it's going to be the master, okay, once we have already configured that, all the setting for the serial line, we need to configure that the PLC will be the master in the communication. Once we configure the master, we are going to be able to we always have the possibility to add the function blocks, but the idea is to configure the hardware part, okay, to be a master. And then on the software, we can use these three function blocks that we have here. One's for read, write, or both of them, write, read, and write and read. So now, when we add this function block in our code, okay, you can see here the instant how we start, read underscore bar, write underscore bar, read underscore bar, and then you have the number. Okay, that will be the instance of those function blocks. Then you have the link, that the link is because the PLC can have Ethernet or another serial line. So we need to define how these function blocks are going to be used. So we need to define that. And the next thing that we need to configure is the ID. And the ID is the address, okay, that the slave device have. Okay, that's why we use in this case number 1, because in the network the other PLC, the M172, is going to be the slave. Let's continue with this. Okay, so each function block, okay, if we go to the theory of the Modbus, we have different functions in order to be executed. So here you can see that the read has these 4 functions, okay, to read for multiple words, okay, it can be, you can see here, if you take a look, if you configure the object type, okay, as 3, 03, you go over here trying to find the 03, here, it can read the holding registers. And the holding register could be the percentage NW of the other PLC. That is something that we're gonna play with it in this part of the training. Okay, and if you take a look, for example, the other one that we have read multiple words, okay, it used the function 04, and the function 04 is for read input register. So if you want to read a percentage IW for another device, you need to use that. So it's important that once you define if you want to read or write information, you need to specify which function do you want to use to read and write. Okay, and this one you have also for write, you have different function blocks that you can see here, the numbers from the code. And this one, the write and read, it uses this function, okay. You can find it over here. No, this one is not. This one, okay, because it's an exa, okay. 23, read write multiple register. And here it's important to check in your device if the slave allows you to have this kind of access. Otherwise, are not going to be able to communicate with the from the PLC, from the M1 to the from the one, no, for the other PLC, from the Modicon M221, in this case, to the M172 or device. You need to check that in the characteristics of the PLC or the other device that you have. So let's continue with this. Okay. Then the other parameter that we need to configure over here, which is perfect, is the first object and quantity, okay, for the read on read, write and read bar, okay. So the first object will be the direction or the address on the other device that we want to read information. In our case, will be this one, okay. Here is something important because we need to check if it's base 0 or base 1. Otherwise, you will need to subtract or add 1 to the address that you have in there. You can test that on the communication. In our case, with the M172, we need to subtract 1 to the address in order to communicate. So the first object will be the address where you want to read information with, and then you have the quantity. So from the initial address, how many registers do you want to read? Okay, that is the information that you need to configure. And then the next one is the index data, okay, or index data in, that basically in this case for read or write read var, okay, that parameter is, okay, I can read from this register from the other device and how many um, the amount of register that I want to read, and then that information will be stored in a position in my PLC in the M221. That is the index data. So if you want to read these two registers from the other slave, the index data will be the percentage MW in the M221 that that information will be stored. Okay, so let's continue with this. Now, what is missing is the write bar. You can see it's similar to the other one, the first offset and the amount of registers or addresses that I want to read, and then the location where I can read the data and then send it out to the PLC. Okay, so now it's possible that we can have a problem on the keyboards or another kind of problems. Okay, so it's important to identify in case we don't have the communication with the other device, how we can identify there is a problem. Okay, so when we execute the function blocks, we can see these two variables over here, com error and upper error. Those two variables allow me to identify what is the problem with the PLC that is not able to communicate with the other device. So we continue with this. Okay. Here is the list, but the complete list of the codes can be found on the help of the PLC. So I'm going to pause this quick. Okay, okay, good. So now the idea is to open our program, configure the device. Okay, so let's do that. So this is our program. I need to configure the serial line. Okay, this project come from the previous unit that we were talking about, the remote display. So now I'm going to configure this as a Modbus. I need to configure over here. I'm going to play, change this. Okay. Now here I'm going to modify this to match the information that we want. Okay. I had to configure before. Let me just double check the information I have. 13181 event 38400. Okay. Okay, the same information. So it's important to match the configuration of the Modbus in both devices in order to make it work. Okay, this is complete. Now, what I'm going to do is to create a new POU, PRG underscore communication, and I'm going to use the read, write read. So here we need to select the, in order to, I didn't explain this part, but if you click over here, you can have a pre-configuration of the device. If you want to see the complete list, you just double click and you can see all the instance, and you have the possibility to configure over here also. So if we go here, the ID is the address of the device that I want to communicate. So in this case, V1, and the first object is the 8336. But I told you that in this one we need to subtract one in order to communicate. And then I want to store this information. Let me see where. In the position 60, and I did the other way around. Okay, so the first right object is the 88720. This one, okay, is for the backlight. So his one is not correct. 89 is one register, and I'm going to check the information from the percentage NW62 to write into this position on the other PLC. Now the first read object is 8335. I'm going to read two registers and I'm going to say that in the 60. Apply. As you can see here, this is a configuration. Going to put some information over here, some variables over here. Okay. And I believe the percentage M30 is correct, is available. Let's see. Okay, so I'm going to put some names over here, N31, N32, N33. Okay, good. So once we have this, we can connect to the PLC and see the behavior, but this is not going to work. I'm going to spoil over here. This is something important. We need to check which are the functions that we can use over Modbus to communicate with the devices. Okay, in here you can see this is the table of the functions that we can use on the M172. So if I want to use the function block for read and write and read, it's not going to work. We're going to have an error because that function that we want to use from the M221 to the M172 from the slave is not going to work. So let's go back to the program so we can see that together. Okay, PC. Okay, perfect. So if I execute now this function block, we're going to have an error. Okay, so if we go to contextual help, okay, grab this, we can see that we have an error. Okay, we can go to communication errors. Okay, good. Communication error, which is the one 254, 254, this one, protocol specification errors. So we need to go to the operation error codes. Operation error codes, okay, I have this one, communication error, and now I have the one, illegal function, okay? As I mentioned before, the function code received in the request is not authorized by the action, okay, blah, 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 which is good. So in this case, as we have this problem, was not a real problem because we should already know this, but we should separate the write and read into different function blocks to use the write and then the other one, the read one. So I had made, let me just go back here, had made another project with this so we can show you much faster this. Just hold on a minute. So you can see it. It's opening in the other window. Okay, now it's back. So it's the same project, the same names and everything, but I had add some symbols now, okay, and I have specified the communication in two different channels, in two different function blocks, one for write and the other one for read. And if you can see here, the write in this case, you can see is the same configuration, the read is the same configuration from the read part, okay. So let's communicate to the PLC now with this project, and let me see if I disconnect from the other one. Yes, it's disconnected. So let's connect. So select the Ethernet. Okay, and download this program. So the idea here is to show you that if we don't check which functions are available from the slave device, we are going to have problems. Okay, that's why I start with the write and read. so you can see the errors. And now, if we write or read from here, we should be able to communicate easily with the device. So let me just go here. Okay, so we are connected with the PLC. Now I'm going to try to read information over here. I'm going to show you the other PLC. Probably you can see it. Okay, yes. So here you have like a small display. Okay, so in order to write the new information, what we need to do is to create an animation table. I believe I already have done over here. Okay, and here we have the possibility to execute in order to write this information. So the information that I want to for the backlight is to send the number 1 to illuminate that. So we need to execute this. You can see we have received the done. As you can see on the screen, it sends the value. Now, if I change this to 0, there is no response over here because this, in order to be executed, this one is not the enable, it's an execute. So we need a new pulse over here to be send the information back. So if I press now this one, it's going to be off. Okay, so this is the behavior. So let's go back here. So now this is for the write. It's very simple. Once you have the addresses and everything, is simple. You just need to execute and send the data. Now, if you want to read information, this is a temperature. So let's see over here. This is the read one. Okay. So the information is going to be reading these two analog inputs from the other PLC, which are in this position. Now, if I execute, these two variables will be changed, okay, because I send the data to this. So execute, you can see the value over here. Now we're going to touch the proof, the NTC, to show you that it's going to change. Just give me 1 second. Okay. Hidden a little bit. Now I'm going to execute again. Okay, there you see, there has changed. Okay, and this value is because there is no proof in the other analog input. Okay, so this is part is for this. Okay, going to disconnect. And this is awesome when you want to only read and write one information. But if you want to execute both of them at the same time, we can have a problem over here. So let me just connect again so I can show you. Let me just change this one. So we're gonna try to read and write. No, this one no. At the same time, just to show you the behavior. Okay, I know the behavior that is not going to work, but I want to show you. Okay, so I'm going to execute this. So it makes the first one, okay, the first write, but the other one we have an error, okay, because we cannot execute both of them at the same time. That's the problem. So we need to make like a sequence. Okay, so that for that I want to show you another example. Okay, let me just log out. No, I don't want to say the changes. Just open the other one. Okay, it's open. Now I'm going to put it in the other screen. Okay, so let's make the same logic over here. Okay, it's the same, but okay, as you can see over here, okay, probably would be much better if I open this and the other one together so you can see the difference. Let me just open the other one once again. See another Windows. A few seconds. Okay, good. I'm going to put this in this part so I can show you the real difference between the two different programs. Okay, and let's put this over here. So as you can see over here, I have these two function blocks. Okay, they are the same, but what I have changed is the order to be executed. So in this part, I have independent variables to execute each function block. Okay, and independent variables over here. So what I have done in here, okay, this is one way to do it, it's not mandatory, is to link the execute done for this one, for the first communication block, to execute the other one only if the other one is not in busy. Okay, so the last element of the function block can execute the first one, as you can see over here. Okay, but in order to start all of this, I have like a initial sequence. So you can add, for example, after the first cycle of the PLC, or after making a homing of the machine, or whatever you want, you can start the sequence of communication. So if we connect again now to the controller, okay, connect to the PLC, the configuration is the same. Okay, I haven't changed anything, only the order. So PC controller, okay, good, play. So I'm going to show you also here the animation table. Okay, good. So now what we need to do is to initialize this, okay, in order to communicate. So I'm going to initialize with this button over here. Okay, as you can see, all the sequence is starting busy, done, and then it goes to the other one. As you can see over here, that I reading the information from the device. So now I'm going to touch the probe, and this one will be rise without doing anything on my side, only just touching the probe to see how it changed. Okay, you can see it's rising. Okay, good. Now if I change the backlight now, one, return on, off, on. Okay, so this is how you can make like a sequence. After the done of one of the function blocks, you can execute the other one, and so on and so on and so on. So this, me check if I'm missing something. Okay, so we have done all this part. This, okay. If you don't have M172, you can use another device. This one is just for test. And then probably is another topic this, but as you can see on the program, I have different instance for different function blocks, and they have a number also. So you can also access to the configuration via the software, so you can change, for example, instead of using different function blocks or too many write or read function blocks, what you can do is to change the variable that is trying to read. Okay, so you can change those numbers because you can access to that information also. So you can access, for example, to the first object. For example, you want to read one position, then the another one that is not continuous. you can do that. You can assign another variable and change that in the logic, but that will require more logic to do it, and probably can be solved with adding another function block, but you have the possibility to do it. So we have seen how we can communicate to a slave device via Modbus Serial using the communication blocks. Now what we're going to do on the next video is to see how we can communicate with the same device, but instead of using the function blocks, the IO scanner functionality. So thank you very much for watching this video, and I see you on the next one.